So welcome to Practical Security for Web Applications. We're going to cover a lot of topics, and you can go to this bit.ly right here, bit.ly/security-slides, and it will download a PDF of the entire presentation with all of the links in there and all the information that I referenced. So you don't have to feel pressure to take pictures, during the presentation or screenshots. You will have all the information in there. This talk will cover a lot of introductory topics. There are a lot of amazing folk getting into web application development, and there are some topics when it comes to best practices for security, which have been around for a while, and a lot of folks have not yet had a chance to acquaint themselves with a lot of these topics. And so we're going to cover them. Many of these topics will seem very familiar to a lot of you. I do add some different angles based on my experience on some of these topics. So that'll be that. And so let's get started. This is me on Twitter, so feel free to connect with me and ask me any questions. Okay, so I'm based in Austin, Texas. So hello. So here's a little bit about me. There's me on Twitter. I have a link to the different talks I give and some background about me. I've done some open source contributions. This Hash Tuner is an open source project I started last year. It's very small. We'll cover that a little bit later. I've contributed some things to some projects as well. So there's that. And again, the slides, you can download them at this URL. Okay. So first, let's look at a high level. Software is everywhere. If you look at banking, healthcare, finance, travel, entertainment, communications, home automation, alarm systems, fire detection, surveillance, military, aerospace. And you will also see a lot of software in the cars that we drive every day. And Tesla, for example, has done some really cool things with kind of autonomous cars that they're trying out. So you might ask yourself, what could possibly go wrong? Obviously, this, right? There are a lot of there've been a lot of security issues in cars, for example, where hackers could remotely kill a Jeep on the highway. That was pretty creepy. That was a 2015 article. And then a couple of years later, they came back, actually in 2016, they came back and did it again. So, there's a lot of security flaws in any software. I think it's helpful to keep in mind what is your exposure to a lot of these security flaws. If you look at your company and if you look at your business data, most often your business data will live in some kind of, you're on your IT network or on your private cloud or your public cloud. And you might interface with your business data through a CRM system, for example, an inventory management system, which are kind of employee facing kind of back-end applications that are not kind of outward facing. And then you might require your employees to get on a VPN network to interact with these kind of back-end systems. At the same time, though, you're going to have public-facing aspects to your business data. You might expose some of it through your website, which has some content on there, or your software as a service application, or your API, right? So these could be outward-facing exposures to your business data, and often this data will be exposed over ports 80 and 443, which are basically your web ports. So one of the things that attackers will try to do is they will try to compromise your employees, so they can compromise an employee's work computer to get onto their VPN to try to attack to exfiltrate your business data from within. Another thing they're going to try to do is try to get at your business data through its public facing aspect of it. And this is what we're going to focus on this presentation today. This is really, we're not going to touch on malware and how your employees can get infected with malware and the kind of best practices for all these things. We're not going to look at that. We're going to look at the existing public-facing aspects to your business data through your web applications. So if you start looking at the business risks when it comes to your data getting compromised, you know, you have data exfiltration with sensitive customer data, you have intellectual property, you have unauthorized operations such as financial crime, competitive business disruption, establishing advanced persistent threats. You know, these are, you know, some of the many things that can happen when your data gets compromised. And there have been a lot of high-profile security breaches. So when you download the PDF, you'll be able to just click on these links, which have, you know, which are numerous articles on different high-profile data breaches, and there are, you know, constantly new ones every day. So you know, you can go check those out. Here in the United States, we've had a number of high-profile ones. Yahoo had some issues. The Government Office of Personnel Management, the OPM, had some issues with 9 million government employee records got stolen. So that's always uncomfortable. Equifax, it's a credit reporting agency here in the United States. They got compromised as well. That was pretty bad. So, you know, there are a lot of articles, you know, about all of these. And so this kind of brings us to web applications, because there are some interesting aspects of web applications that make them especially compromisable. First of all, there are millions of websites and applications out there. And it's very easy to automate the scanning of all of these websites and all of these web applications using automated tools. There is a lot of sensitive information behind those web applications. They also present a very large attack surface with a ton of attack vectors, which, you know, we're going to look at later on in the presentation. And also there are things like denial of service. You know, we're not going to really talk about this. I have a separate talk on that topic, but it's another big nightmare. It's when people try to take your application down because they can. So today we're going to look at some strategies, you know, for improving our security posture. And I want to set expectation that, you know, in my opinion, and it's also the prevalent industry opinion, is that, you know, there's no such thing as security in absolute terms, right? The best we can do is make ourselves less insecure, and by having, you know, just kind of many layers to kind of improve our security posture. So one of the first things we want to do is to educate humans. When we do that, we're going to discuss a little bit about, you know, code reviews and what happens when things are pull requested. The next step is to look at kind of our CI pipeline, look at different tools for automated code scanning. Then we'll look at different tools for dependency vulnerability checks, because part of a winning strategy is to, first of all, educate humans, but, you know, we're not going to catch everything at all times, and having tools to kind of help us out to catch additional things that we may miss will help us out. So code scanning is part of it. Dependency vulnerability checks. So here, this is an open source. It's a conference about open source software, and we use hundreds of libraries that are open source on any project. And if you look at Urima's talk and Jennifer's talk, if you look at all the things that it takes to make a open source project successful, there are many things that can go wrong where security flaws could get introduced in those projects. And having tools to stay aware of these security vulnerabilities and kind of notify you and allow you to upgrade them automatically or semi-automatically will definitely improve your security posture. Then we'll touch on automated penetration tests. We'll look at web application firewalls, and when all else fails, you know, we'll mention logging. So the bolded topics are the topics that we're gonna, you know, look at today. And below this red line, you know, I like to call out the importance of trying to catch security flaws above this red line, because when you catch security flaws below the red line, then the cost kind of goes up pretty dramatically, because it kind of means that your code is already in the wild. So So at the top of this pyramid over at the top of this waterfall here, at the top left, we're going to talk about educate humans, because this is the thing that it is the first line of defense that is critically important. So to educate humans, I like to reference OWASP. It's an organization that's been around for a long time. I highly recommend anybody who works in web application development to spend a lot of time on OWASP.org. We're going to reference their work heavily throughout this presentation, so I highly recommend them. So the thing about OWASP is they advocate okay, so all right, so they advocate approaching application security as people, process, and technology, and I think it's a really good way to look at it. They regularly publish their OWASP top 10, which is a list of top 10 vulnerabilities, and in this presentation, we're going to touch on some of those top 10 vulnerabilities. As far as the things that I've seen out there in the wild that have been, pretty impactful on applications that, that I've worked on since the, mid 90s. So here's a URL to the OWASP top 10. So definitely spend some time on it. So that's kind of to educate humans, and we're going to come back to these vulnerabilities. But now I want to touch on tooling, right? Because as we just talked about, tooling is an important aspect to supplement our security posture. And first off, let's look at CI, continuous integration, and how you can weave tooling into your overall CI strategy. So there are a lot of CI frameworks, and I believe later on today, there is an in-depth section on GitHub Actions. So I highly recommend that you check it out. But I've worked with Circle CI as well. And I use it on my open source project. On some other projects, I've worked with Travis CI. It works really well as well. You got Jenkins, you got TeamCity. I mean, there's a bunch of ecosystems to build CI pipelines, and whatever works for your project, you should check it out. So yeah, so I've worked with these in Jenkins as well. So if you look at different security tools, as part of your CI, you're going to have a static code analysis of your source code from a security standpoint. Also, what you're going to try to add in your CI pipeline are dependency vulnerability checks. So these things happen while your code is moving around. Once your code has been deployed, let's say on a development or staging server, it's a good idea to look at automated penetration tests. You want to have a lot of these automated penetration tests happen on your development and staging servers, because once your code gets in the wild, you get penetration tests for free, because hackers are always, trying to compromise your application, right? If you tell your logs on any application that is live, you will see constant attempts from automated tools to try to break into your application. I mean, so you get penetration tests for free in the wild in production, but you want to make sure you catch issues long before that, right? So I'm going to show you kind of a possible way to set up a CI pipeline. There are different ways of doing it. These are some of the things that I've done with my teams. So when there's when you push a code change, you may have a Git hook that might trigger your continuous integration pipeline, on which you might run your unit tests as well as your integration tests. And then you might start your static code analysis, where you're going to analyze your code using automated tools, which will analyze your code from two standpoints. First, from a quality standpoint, and also from a security standpoint. So quality is kind of a lot of smell tests to figure out how maintainable your code is. And then security, that's kind of the main topic of this presentation. And then once you've done your static code analysis, that's when you're also going to fire up your dependency vulnerability checks. Again, that's to detect which of the open source software packages you're using in your application have known vulnerabilities. So let's say you pass all of those checks. That's when you might deploy your code to a server. It could be development, could be staging, for example. And then that's when it's a good idea to start doing automated penetration tests against the code that is deployed. So that's kind of a, one way of doing things. Different teams do things slightly differently. So I just kind of wanted to call out all these moving parts so you can make your own educated decision as to, defining a winning strategy for yourself. Okay, so now we're going to look at some of these tools in a little bit of depth. So I've kind of harvested a number of open source tools for every category. And there are also a lot of good commercial tools, but I try to avoid plugging commercial tools because then it kind of becomes more contentious. So right now I'm just going to try to stick to free open source tools. So first, let's look at automated code scanning tools. So here we go, also known as static analysis. And the goal of these tools is to find vulnerabilities in your code, in the code that you wrote. Okay, so OWASP has a list of source code analysis tools. I highly recommend checking it out. I've used SonarQube. So the nice thing about SonarQube is it's a pluggable architecture, and they have plugins for pretty much every language out there. If you're trying to scan code in a PHP application, I've used the Sonar PHP plugin for SonarQube, and that's worked really well. But there's also some other programs you can use. There's Prog Palette. You got PHP CS Security Audit. If you're working with JavaScript, you can use SonarQube's Sonar.js plugin to analyze your JavaScript code. If you're working on C#.NET, there is a project called Security Code Scan. If you're working in Java, there's FindSec bugs, spot bugs. And then if you're working in Ruby, you got Brickman Scanner, Ruby Gems, you got Bundler Audit, Dawn Scanner, Sonar Ruby as well. So yeah, there you go. Again, you have all these links available in the PDF. So you can, check all those out. And then for Python, you have Bandit and Sonar. Oh, sorry, I skipped Sonar Python as well. Okay, so that was for code scanning. Again, finding vulnerabilities in your code. Now we're going to look at dependency vulnerability checks, and that's to find vulnerabilities in the open source libraries which your project may be referencing. So it's vulnerabilities in third-party code. All right. So if you're looking at a multi-language framework, OWASP has built a tool called the OWASP dependency check. If you operate in PHP, there's Rove security advisories, which works really well for new packages. So anytime you introduce a new package to your composer, it will or anytime you update one, it will automatically find any security issues and encourage you to upgrade it. And then the Friends of PHP project has another package called security advisories. And so this will do a full end-to-end inspection of your composer.log file. So it's a bit slower, but it's comprehensive. And then you have in JavaScript, there's a tool called retire.js, kind of a play on require.js. What you require might need to get retired later, right? So retire.js. Okay. And then in Ruby, you have Gemsurance, you have Bundler Audit, and then you have Ruby Advisory DB. Okay. So these are the ones that I could find so far. whichever language you happen to operate in, I highly recommend that you try to look for similar tools as well, right? I try to list the tools that I could find. Okay. So that was for dependency vulnerability checks. So now let's move below the red line and look at automated penetration tests. OWASP has created a penetration testing tool called OWTF, which does not stand for what you might think it stands for. It actually stands for Offensive Web Testing Framework. They've also made another project called the Z attack proxy. And so this one, you kind of combine it with web browsing, and then it'll help find vulnerabilities in your project as well. There's also the age-old Metasploit. So Metasploit is a very comprehensive penetration testing framework, which was designed to do far more than just web applications. But it is still a very good tool to find web application vulnerabilities as well. So Metasploit is still there. Okay, so that was for automated penetration tests. Let's touch briefly on I'm seeing in the chat, Meg was asking for sharing the slides. Yes, I have a URL to get the PDF, so I will be sending you the PDF to the slides. Okay, there you go. Somebody pasted it. Thank you. Okay, so let's look briefly at web application firewalls. So I always advise a lot of cautions with web application firewalls. The goal of a web application firewall is something that you put in front of your web application, and it's supposed to catch data exfiltration attempts, hacking attempts, and it's supposed to recognize patterns and block them. However, false positives are a thing, and it's a big problem. You've also, you've got false positives and false negatives. So false positives is when your firewall thinks that somebody is trying to hack you, but it's just you're running a forum and somebody is, putting a post, a harmless post in your forum, but that your firewall blocked it because it thought that it was a hacking attempt, right? And then you have false negatives where people are in fact actually trying to hack you, and then the firewall just doesn't find it. And I found it in my experience I found false positives to be a big issue on applications where you have a lot of user generated contents, like forum sites, right, where people write a lot of comments which can have almost anything in them. So it's something to be mindful of very often. Yeah, script. Very often they do need proper tuning. But so there are some open source WAFs out there. You got Mod Security. There's an Nginx plugin called the Lua REST Web Application Firewall. There's another one called the NAXI plugin. So I've used other firewalls. There were commercial solutions that were well supported, and I found a lot of flaws in those. I have not worked directly with these open source ones. So again, just be mindful, do a lot of testing. So whether it's a commercial solution or an open source solution, make sure you do a lot of testing and expect a good amount of tuning to happen. Okay. Oh yeah, and then Shadow Daemon as well. All right. So, again, look at this as sort of a waterfall, right? You want to try to catch issues at the top left of this waterfall, right? You want as few issues to happen at the lower layers as possible. You want your humans to be educated well enough to be mindful of as many issues as possible and to catch them upstream. But if the person writing the code doesn't catch an issue, then you hope that when the pull request happens, one of their peers can find the issue. And if the peers don't find the issue, then you hope that the automated code scanning can find the issue, and then that doesn't work. You hope that your dependency vulnerability checks, that's kind of how it works, right? So it's kind of putting as many layers as possible to put yourself in a position to succeed. To answer your question, proper tuning, for web application firewalls, the question is, what does proper tuning of web application firewalls mean? They have virtually all web application firewalls operate based on a library of patterns for known hacking attempts. These are patterns that you will see in a request. And those patterns look a little bit like regular expressions, kind of string patterns. And so sometimes you can modify those patterns yourself. You can add your own, right? And that's kind of where the tuning process kind of comes as part of this. So, all right, let's keep moving. So this concludes the tool section. Now we're going to start jumping back to educating humans, and we're going to going back to trying to understand vulnerabilities. And in the world of vulnerabilities, I like to look at two major buckets. One are low-level vulnerabilities, and another one are application vulnerabilities. And we're going to get into those. So first, let's jump into what I'm calling low-level vulnerabilities. And among those, you've got injection vulnerabilities such as SQL injection and NoSQL injections, because yes, those are possible in NoSQL as well. You have cross-site scripting vulnerabilities. You have cross-site request forgery vulnerabilities. So these are some of the very common low-level vulnerabilities which I've seen impact a lot of web applications. Let's start digging into them. First, let's look at SQL injection. So for those of you who've been around for a while, there's this old school XKCD comics. It's called Bobby Tables. I'll spare you it, but you can look at it later. The old Bobby Tables joke. So the impact of an SQL injection is you can leak, destroy, override, or insert data. You can escalate user privileges. There are a lot of things that you can do. And the vector is very simple. An SQL string is a database query. And so most often we need to insert a variable as part of a database query. Where the vector of vulnerability is when somebody, whichever language you operate in, you just blindly insert a variable reference inside of your SQL string. So here's an example in PHP. You got your SQL statement, select star from users where ID equals, and then you just put $ user ID, and you retrieve your user ID from the request, and you just blindly plugged it. This allows an attacker to actually modify your SQL statement and make it do things you did not intend to do. So that's the basic vulnerability. And so people talk about sanitizing your inputs, and I say no. Sanitizing inputs is not a solution to preventing SQL injection. There is one solution that is effective, and it's using prepared statements with name parameter binding. Yes, it is a good idea to sanitize your inputs when it makes sense. If you're expecting to have an integer in your variable, make sure that it is an integer. Okay, fine. But sometimes, you're expecting user-generated content. Again, you're running a forum site where people are expected to enter free-form text. There's only so much sanitation that you can do there. And also, the thing about input sanitation is in the end is going to be brittle. So if you want to use input sanitation, definitely do it. It's fine. Just know that that's not going to make you secure. What is going to make you secure is to use prepared statements, because you basically cannot inject a prepared statement. So this is kind of a little bit what it looks like. you go select star from users where ID equals, and then you go :ID, and then :ID is the name of the variable. Another way to do it is with question mark. So sometimes you will see select star from users where ID equals question mark. That's fine too. I like to do named parameter binding like this using :ID because it makes things more human readable. I kind of like knowing what I'm looking at, right? So that's it. OWASP has a cheat sheet on this, a query parameterization cheat sheet, and it shows you how to do it in every language with every platform. It's really easy to do. So as I mentioned earlier, input sanitation is okay, but it's brittle and it's not sufficient. If you do input sanitation, just know that it is not enough. Make sure that you use prepared statements. If you remember, one thing of this presentation is use prepared statements when interacting with your database. So a prepared statement is pretty simple. I showed you an example earlier. And whichever language you happen to work with, there's going to be a function or a method that you can use to bind the variable named ID, :ID, to an actual value. And when you do that, even if you do no sanitation on past user ID, you're still not going to get injected because with this mechanism, you're making your RDBMS look at things differently. It looks at the query and it looks at arguments to the query, and they're two very different things. So here's an example on how to do it in PHP using PDO. That's one way to do it. But so now let's look a little bit at object relational mapper. Most often in our web application code, we don't always issue raw SQL queries. We tend to work with a layer of abstraction over our data layer. And this is where an ORM comes into play. And those can be SQL injected under the right circumstances. And so we need to be careful. On the Java platform a while back, using the Hibernate query language, there was an injection that was found and documented into this incident. So you can read it. So in PHP, I've used Doctrine ORM, which follows a lot of very same APIs as Java's Hibernate as well. So that made me mindful of that. So the OWASP, again, OWASP has a page dedicated to testing for ORM injection patterns. So, make sure you check this out. So if you work with ORMs, there are many types of ORMs, but in my experience, I've come across two prevalent types of ORM. One are active record pattern ORMs. So if you work in Ruby, you have the Ruby active record. If you work with Laravel and PHP, you have the Eloquent ORM as well. I work most with data mapper pattern ORMs. So in Java, I've worked with the Java Persistence API, JPA, of which Hibernate is a reference implementation of it. The Doctrine ORM in PHP, and then in .NET, I've also worked with Entity Framework. That's Microsoft's excellent ORM framework. So, so these are some of the ORMs out there. So you got Active Record and Data Mapper. So let's look at Data Mapper ORMs. One thing to keep in mind is if you're using Data Mapper ORM, at some point you're going to make a query from an object, select from the right object where the destination properties ID property equals a past destination ID. So if you do this, you are offering an opportunity for somebody to pass a nefarious value to the right destination ID parameter, which could allow somebody to alter the makings of your DQL string, which could conceivably expose a vulnerability to kind of also hack the underlying SQL that gets generated from your DQL. So a better way to do this, so again, you want to avoid concatenating strings like this. A better way to do it is you just kind of reference objects, right? Select your ride where the ride's destination property equals the destination object. And so that's a nice thing with a data mapper query language is you can actually reference entire objects. Behind the scenes, the data mapper engine is going to know to compare the ID attributes of your respective objects. So then once you have colon destination as the variable referenced in your data mapper string, you can bind this parameter to an object, very similarly to how you do it with a good old SQL string. So that was an example in PHP. So this is, wait, sorry, it looks like I had the same slide twice. Okay, so anyway, if you are working in the Microsoft Entity Framework, I have a link here to their security. They have an entire page dedicated to security considerations. So if you operate in .NET, check out this URL. So that was for data mapper. Now I want to briefly touch on active record. So some active record engines, such as Eloquent in PHP, have raw methods. So if you have an object user where raw, and that's where you can put kind of a query snippet where you can inject a variable that just came straight from the request, right? It provides an opportunity for you to do this. And so if you want to use this where raw method, make sure that you don't do what I'm showing you here on the screen, where you're just kind of injecting a variable in the middle of it. Because if you do that, again, you provide an opportunity to alter the logic of the statement. A better way to do this is to stay away from the raw methods and to leverage your active record engines where constructs, where all of these are separate arguments that are nicely separated. So these won't be injectable. So that's that. If you operate in Ruby on Rails, there's an entire site dedicated to learning about Ruby on Rails SQL injections. So highly recommend that. Okay, so the point about ORMs is they do provide you with a very expressive vocabulary to interact with your data. They make the safe way convenient. However, you can and you will still get owned if you don't use them as intended, right? I mean, that's the thing about that technology. So, all right. So now let's look at NoSQL injections, because yes, NoSQL can also get injected in some exotic ways. So I have a link here, again, to another OWASP resource for testing for NoSQL injection. So when you get the PDF, you can just click on that and you will go to OWASP's excellent site on that. I have an article here about hacking Node.js and MongoDB, so you can check it out as well. So I'm going to show you a little bit of an example of a vulnerability pattern. So you may have like a collection against which you're doing a find, and then at some point you're comparing two values, being less than 0. But now instead of this 0 variable, you're gonna put user input there, right? So instead of comparing to the a hard-coded 0, you're going to compare to a variable called user input, which has some has some data that came from the user. Well, if somebody were to pass as the value of user input, if somebody were to pass this big old value here, well, what that's going to do is that's going to cause a denial of service on your CPU, where your CPU will max out for 100% for 10 seconds. So that would be uncomfortable, right? And so that's one example of how people can mess with you using NoSQL injections. So there are some better practices to mitigate against that. So I have an article here from DZone on how to do it. They recommend to cast query arguments to string. So if you have a username, you cast it to a string. If you have a password, you cast it to a string. However, please don't store passwords in plain text in your data store. Please don't do that. And we're going to touch on that at the end of the presentation. So that's that. That's the exciting world of NoSQL injection. Okay, so now in the realm of low-level vulnerabilities, now we've just looked at injection vulnerabilities. So now we're going to look at also in injection vulnerabilities, it's called cross-site scripting. So most of you have come across this, but it's always good to have a refresher. So in the world of cross-site scripting vulnerabilities, the impact could be any number of things, right? Could be credential theft, unauthorized operations, data leak, session hijacking. There's a lot of bad things that could happen there. So the vector is very simple. There's two types of vectors. One is called reflected. Imagine your search results page, right? When you go to Google and you search for something, and then you search for flowers in Google, and then when you hit return, you get to this search results page, and on that search results page, it shows you the term that you search for, right? So if instead of flowers you put a script tag in there, well, then that wouldn't be good, right? So this is what a reflected attack looks like, right? You have google.com/search q equals, and instead of flowers, you put script alert pwned, right? That's one way to do it. And so in the HTML document that is served back to the end user, now you have, it says, here are your results for, and then you're just going to blindly outputting the value of the Q parameter that is sent in your get argument, right? And then if you do that, then an alert is going to pop on the user. And so that's a very simple reflected vulnerability. And then there's what's called stored XSS, cross-site scripting vulnerability is when somebody, let's say you're running a forum web application, and so somebody makes a post on your forum where they put a script tag in there, and then that post gets saved to the database. And then when users load the forum thread, your post gets re-echoed with whatever they put in there, right? So this is them putting a bad script in whatever they save, and then this is the forum in a div re-echoing that back to all the users of the forum, right? So then they can all get owned. So that's stored XSS, at a very basic level. So let's look at mitigation strategies, and most of you probably have heard of escaping or encoding. And here you can pretty much use escaping and encoding kind of as the same meaning. So the basic mechanism for escaping and encoding is to convert characters which are risky for a specific medium to an encoded version, right? So here's an example. I have a script tag that says alert hi. So if I am going to take this and show it in an HTML page, then I'm going to try to HTML encode or HTML escape it. And this is what the string might look like. Let's say I am operating an API, like a JSON API. Then this is what it would look like, right? In JSON, we don't care about angle brackets, but we do care about double quotes, right? So the JSON encoding mechanism puts backslashes in front of double quotes. Right away, you can see that from one medium, HTML, to another, JSON, each medium cares about different things as to what it knows to be nefarious. And this leads me to the questions, when should we escape? And so, should we escape when we render things? And my answer to this is yes, every time. Your HTML rendering engine should protect itself. Your JSON output engine should protect itself from data. It should never trust any data that comes to it, even data that it believes to have already been escaped. This is your last line of defense when you render, when you stream your data out, and you got to make sure that whichever medium by which you stream your data out, whether it's JSON or HTML or CSV output, anything, you make sure that each medium knows how to protect itself. Never trust data. So then the question comes where, should we try to escape things just before storing information, right? If information enters our system and we store it somewhere, should we try to escape it before we store it? And my guidance there is I would avoid doing that because there are a number of problems. For one, as we just saw, an encoding scheme is always specifically targeted to a given medium, right? The way you escape things for HTML are very different for how you would escape things for JSON, which is very different for how you would escape things for CSV, for example. And you never know which medium your data is going to be sent to, right? I mean, you're storing your data in your database, but your data could be sent to any number of mediums. So to try to escape this data is, to me, kind of a losing proposition because there's really no single encoding scheme that is safe and usable for all mediums. And because your stored information is never bound to a single medium, it could appear on any medium. And then the other thing that you can run into are double encoding issue, right? Because as we talked about, you always want your rendering engine to protect itself, to never trust what's coming from downstream of it. So you're always going to have encoding on your front end. But if you also encode when you store the data, you could run into double encoding issues, right? And to visually represent that, imagine you have user input that goes to your rendering engine, which could be output HTML, JSON, CSV. And so your rendering engine is going to protect itself, is going to HTML encode things before streaming to HTML, it's going to JSON encode things to output to JSON, and it's going to CSV encode things before outputting to CSV. But then your user input, so that's when your user input goes straight, through like a reflected mechanism. It goes from user input, straight to your rendering engine. But most often your user input gets to your data storage, and then it goes into your rendering engine, right? So this is where I'm saying avoid encoding here, okay, because of the reasons we talked about in the previous slide. And also, as I mentioned at the end of the previous slide, by avoiding to encode here, since you're already encoding on the right side here, you can avoid double encoding. So there you go. So now the question is, if we are storing data, is there anything that we can do to harden the stored information? Can we still make it relatively safer than it used to be? And my answer to this is absolutely yes. In many instances, you can. But instead of escaping or encoding things, try to focus on stripping things, where you actually remove information, you remove characters that do not need to be there for your use cases. You can't always do it, but if there are opportunities to do it, try to delete things that should not be there. For example, you could try to strip all HTML tags. That's pretty trivial to do in virtually any technology stack. If you do not expect people to be contributing HTML content, then strip all that stuff. That's like one less thing to worry about that you don't have to encode or escape later on. But also look at how you store your data in your data schema, right? So if you're using numbers, don't store them as characters. If for example, if you have like the concept of 10 pixels, 10 px, you might store the integer value as 10 and then reference a unit. Pixel is a unit, is a foreign key to the unit table of unit ID 1, for example, right? That's one way to do it. So like I said before, escaping on rendering should only be done, escaping or encoding should only be done in rendering, so you can avoid double encoding. So there you go. So I have more content here about escaping at rendering for cross-site scripting vulnerabilities. Again, OWASP has a cheat sheet about this, so check it out. I have a little bit of a TLDR to follow, but seriously, please read that page. It is really good. You know, they mention if if you're building an HTML page, never put data that could have a user input in there, like which is basically untrusted data, in script blocks or an HTML comment, an HTML attribute name. The HTML attribute value is okay, but the HTML attribute name is not good. An HTML tag name, CSS blocks, because in those areas of your HTML document, there isn't an escaping or encoding mechanism that is reliable. So don't do it. If you are operating an API that is supposed to output JSON content, most often when people interact with your API, they interact in it, you know, in a web browser just so they can test it. Well, if you're outputting JSON, but your content type is of text/HTML, your web browser is going to be like, oh, this is not a JSON output. This is actually an HTML document. And your web browser is going to see this this script alert tag here, and it's going to pop an alert, right? So make sure that you set the proper MIME type on the content type header on your JSON API. So here's an example of what it should be: content type application/JSON. That is good. Okay. All right. So inside an HTML document, you can use HTML entity escaping of everything. If you put some JavaScript blobs in your HTML, you can use the Yahoo's JavaScript serializer. If you have URLs, you can escape URL fragments. If you operate in PHP in the Symfony and Laravel frameworks, you get a lot of things for free using the Twig templating engine. So that's kind of, you know, what it looks like. You just reference the variable, and then the data will be automatically escaped for you. So if you operate in .NET, the Razor engine also has your back in there. So here's an example of it. So yeah. All right, so now let's look at cross-site request forgery. So this one is a good amount of fun. The impact of cross-site request forgery are unauthorized operations, unprotected transactional operations. Sorry, the impact is unauthorized operations, and then the vectors is unprotected transactional operations. So here's what it looks like. Let's say you are a web application, like you are a social bookmarking website, and you are called victimsite.com because you are going to be the victim. So you put a form which allows a user to save a new bookmark to their list of bookmarks, right? So you have like an action of bookmark/add. It's a post. You have 2 parameters. That's the bookmark title, the bookmark URL, and then you have a submit, right? So if the user is logged into their account, they can click save bookmark, and it's going to save the bookmark to their bookmarks, right? Very easy to do. Now, if your form, if this is what your form looks like, an attacker could do this. They could create an attacker site, and they could attract people to their website, and behind the scenes they could make a hidden form that it's a form that is hidden, and it directly references your website. You know, its action is actually, its post action is actually the full URL to your website, victimsite.com/bookmark/add, with a hidden input parameter that is hard-coded to a value that they want for the name, for the title, and same thing for the URL, right? So this whole form is completely hidden, and a user cannot see it. So when a user visits attackersite.com, this form is going to be in scope, and then this little script here is going to execute automatically, which is going to submit this form automatically behind the scenes on behalf of the user visiting you. So what happens is, if the user happens to be logged into their account on victimsite.com, then the user will have some site added to their list of bookmarks that they did not intend to put in there. And they're like, how did that get here? Unbeknownst to them, they visited attackersite.com, and that's attackersite.com did that behind the scenes. So that's one of many examples. What I used here was a very simple example, innocuous example. So to mitigate it, you can use a unique token in all transactional forms. Leverage your MVC framework to build a form. Make sure that CSRF protection is enabled in there, and most frameworks automatically handle this validation for you, so you do not have to reinvent it. But if you want to see what it looks like, it's very simple. What you do is you add this extra hidden token to your form, and that's a non-guessable token, so that when the attacker site tries to replicate your form, they're not going to be able to replicate what that token is, and that's kind of the basic gist of it. So in PHP, so if you work in Symfony or Laravel, they each have articles on how to use CSRF, so it's pretty simple. If you work in .NET, they have an article as well, so you can check that out. There's examples of it in the wild. I've had a bit of fun with that in the past, but I'm not going to get into that. Okay, so that was for low-level vulnerabilities. Now let's look at application-level vulnerabilities. And we're going to look at three things. We're going to look at user authentication. We're going to look at OAuth security, and then access controls and multi-tenancy. All right, let's first dive into user authentication, one of my favorite topics. So this is, what to do anytime you have user registration and login and password verification, kind of, how to deal with all this stuff, right? So again, OWASP has a handy dandy cheat sheet. So I have a link to that here. So go and check it out. I've compiled some better practices here, peppered with some of my own experience as well. So we're going to look at a bunch of topics. We're going to look at failure messaging, failure handling, multi-factor authentication, account recovery, password policies, password hashing. I actually have a talk, a 30-minute talk dedicated to password hashing alone, but we're just going to fly through it really fast. It's like, woo, hello. All right, password transport, session duration, and reauthentication. What happens when there's a compromised account? So let's dive right now into failure messaging. So we're going to touch on all these topics really rapid fire. So first off, failure messaging. It's basically what happens when somebody types a username and a password and they enter the wrong information. My point here is don't give away intelligence as to the existence of an account. You want to keep the error messaging generic and vague for all failure modes. Do not say any of these things. Do not say wrong password, like, hey, buddy, you gave me the right user ID, but the password is not quite right. Can you give me another password? Right. You don't want to say that. You don't want to help them. You don't want to say wrong user ID, because now you're telling them that this user does not exist in your system. So that's intelligence that you're giving them. You don't want to say account disabled. It's like, oh, yeah. No, this account totally exists in the system, but look, they haven't paid their bill. So, they're disabled. You don't want to give that information. So you want to keep it as generic and vague as possible. And here's an example. Login failed, invalid user ID or password. That's good. That's nice and vague. You do not give the attacker too much intelligence. Okay, so now let's look at failure handling. And it's basically, how do you handle repeated attempts at brute force logging in, right? How to mitigate brute force login attempts. And that's difficult. You might consider limiting failures by IP address, right? If a given IP address gives you more than 10 failures, then, just kind of block them for a while. With this said, a lot of folks are behind, shared networks, and that, you could be blocking people you don't intend to block. So that can be tricky. You might consider putting CAPTCHA, those, show me how many bikes are in this picture, right? To mitigate scripted attempts at brute force logins. But that's a really good way to alienate users very quickly. So again, that's really not a great solution either. What you might do though is to at the very least you can log all failures. You could log the attempted user ID, timestamp, and the IP address of the person. You might also try to consider login successes with the same fields, because sometimes accounts get compromised, and so you may want to capture this forensic information as well. So, all right, so that was for failure handling. Here's multi-factor authentication. So I have an article on Wikipedia that explains that. That's when you use like a phone or an external device to enter a code, for example, right? SMS, be careful of SMS. I use it, I like it, but sometimes phones do get lost or stolen. Also, carrier accounts get hijacked. I have an article here that kind of chronicles different aspects of SIM cloning, where phone accounts get cloned. So that's always something to keep in mind. Now, if you send SMS verification text messages, don't disclose your website in your SMS text message. Don't say, yoursite.com in the, here's your code verification for, yoursite.com. Don't mention yoursite.com, because if a person's phone gets stolen, now you're giving the thief kind of some intelligence as to the fact that they've been using your site to do things on it, right? So, if the phone is lost, don't give its finder any idea. Okay, so that was for multi-factor. Let's look at account recovery. Again, a cheat sheet here from OWASP on what to do with what to do in cases of forgot password. I have an article here on dealing with security questions, where security questions answers should be hashed, and we're going to look at password hashing. But what scares me is there are a lot of applications out there. When they ask you your mother's middle name, for example, they store this information in clear text. They don't hash this information, which means is if their database gets compromised, to me, it's even worse than your password being compromised, because now what gets compromised is very personal information about you. So if you're using security questions, make sure these get hashed, and we're going to look at what kind of hashing later on, but you should be hashing them similarly to how you would hash passwords. A pretty decent way to do password recovery is an email with a one-time reset token. However, try to not let the token URL linger in the web browser. Try to redirect right away, right? So in the email that you send, there's a URL with a token embedded in it. When they click on that link and they arrive at that link, try to redirect away from the token in the URL, because if the token stays in the URL and the person, but then the person clicks to another website on your site's navigation, for example, then that token is going to show up in the HTTP referrer. So just try to be mindful of that. Try to expire the token quickly, no longer than 24 hours. And also do remember that email accounts do get compromised, right? So it's not a foolproof way to do things. Also, beyond email recovery, one-time code over an SMS or some other side channel works. But again, remember that phones do get stolen, lost, and then SIMs get cloned. So when an account does recover, to make sure that you invalidate all existing sessions. Okay, so if the user appears to be logged in anywhere, but an account recovery just happened, make sure that you log out all the other sessions that this user may have at the time that they completely successfully complete the recovery. All right, so now let's look at password policies. So it's kind of, what what should the password look like? First off, you should forbid users from entering a password that is from a list of known passwords. So there are open source lists of known passwords. These passwords were gathered from sites that have been hacked and cracked in the past. So I have a link to a small list. I have a link to a big list of known password maintained by Daniel Miesler. So this is on his GitHub. So you should check it out. So you should try to weave these lists in your application. And if a user creates a password that matches anything on those lists, you should tell them, nope, sorry. You should, you should track the user's passwords and try to forbid them from entering a password from their last 5 passwords. You should try to have passwords whose length is 10 characters or more. And we're gonna look at that a little bit later on. The password should not contain the user's username. And it should try to have at least 3 of the 4 available character types. So lowercase, uppercase, numbers, symbols. You might consider making users change passwords every 3 months. However, this practice has been debated. So I have an article here to the discussions. Windows 10 server apparently is dropping their password expiry. So that's something to keep in mind. Let's look at password hashing. So password hashing, and again, I have an entire 30-minute talk covering this. So we're going to stay at the surface. But basically, you should assume that your user database has been stolen by hackers, and you don't want those hackers to have to know the passwords that your users put in there, because chances are your users are using the same password on multiple sites. That's just, you know, a lot of what happens. So you don't want to give them that intelligence. And so password hashing makes it very difficult / impossible for hackers to know your users' passwords. So when they get your database, all they see are hashes, and they can't do anything with those hashes. Hashing is a big field. Hashing was actually used as a message. The concept of hashing was introduced as what's called a message digest. Hashing was invented to determine the integrity of a message, to verify that a message was not modified between its origin and its destination. And that's what a message digest was originally made for. And that's why the early hashing algorithms were developed. These hashing algorithms were not developed or designed for password hashing, right? So you have hashing, and password hashing is a subset of hashing with a lot more stringent requirements. And while you have some good while you have some good hashing frameworks like, the SHA variants that are good for message integrity, they're not good. They're not designed for password hashing. They're 2 very different use cases. So if you are doing password hashing, you should be using an industry standard hashing framework, which was specifically designed for password hashing. And some of its features should be, it's a multi-pass, algorithm, which will put a lot of strain on CPU, a lot of strain on memory. It should have a unique salt baked into the hash. Bcrypt has been an industry standard for a long time, and it's still okay. People are building rigs dedicated to Bcrypt cracking. With this said, they're still very not practical, and I'm going to show you an example of it. Trying to anticipate trying to anticipate future vulnerabilities in Bcrypt, there was a password hashing competition that was completed in 2015, and a new algorithm emerged out of this competition called Argon 2. There are some questions though, and we're going to touch on that, but Argon 2 is supposed to be the latest and greatest in password hashing. With this said, there are things to be mindful of. So we're going to touch on those in a little bit. There's a great article here by David Whitlock that compares these different hashing algorithms. And so for now, bcrypt is still good. All right. So I highly recommend following a company on Twitter called TerraHash Corp. So I have a slide here that you see. It's going to be difficult to see the slide, so I'm going to read it out to you. But if you can see at the top here, this Twitter URL, it says TerraHash Corp. So you should check out TerraHash Corp on Twitter. They put out a lot of research. So what this company has done is they have built super high performance clusters of like password hashing, password cracking rigs, and they offer password cracking as a service. And every once in a while, they publish how long it takes for their rigs to crack passwords based on different hashing algorithms. So at the top are the weakest hashing algorithms, and then at the bottom are the strongest hashing algorithms, right? So it goes from weakest to strongest. So if you look at the second line here where it says MD5, it shows you that even with a password of 9 characters, they can crack that in 9 hours, even with MD5, right? Even a password of length 10, they can crack that in 1 month with MD5, right? That's why I'm saying don't use MD5. With the SHA variants, right? If you go a few lines down, for a SHA-2 512, it will take them 2 years and 4 months to crack a password of length 10 on their rig. Now, if you go all the way to the bottom, though, to bcrypt, which is has been an industry standard, a password of length 10 will take them 167 million years. A password of length 9 with bcrypt will take them 1.8 million years, right? So you can see the relative strength. But one thing is for sure, though, one of the most significant things you can do to improve your security posture is to increase the number of characters in your user's passwords, right? Because if you go to 13 characters, it will take them, even with NTLM or MD5, right? At 13 characters with MD5, it will take them 91 million years to crack a password. So, having a lot of characters in a password, 13 or more, is definitely very impactful. With this said, though, make sure you pick a good hashing algorithm, and bcrypt is there. So as you can see on this chart, Argon 2 is nowhere to be found, right? So why did they not list Argon 2 on their research? And so somebody actually, whoa, I died. Am I here? Oh, okay. Yeah, I am here. Sorry. Looks like I accidentally got, oh yeah. Okay. I accidentally got out of presenter mode. Okay. Okay. Sorry. I'm back anyway. Yeah, because I clicked the image. So as you can see, Argon 2 is nowhere to be found on their chart. So somebody actually asked them about that in this Twitter thread. So again, it's difficult to read on the screen, but you will see it in the PDF. But somebody asked about Argon 2. And they ended up saying that some of the folks who worked at TerraHash, J.M. Gosney, were actually part of this password password hashing competition in 2015. They were kind of on the judging panel, and they realized after the fact that it was not a good password hashing algorithm, and so they don't recommend it. I don't quite understand why, but this is the thread here. So for transparency, so For now, I would say bcrypt is still good. It is still strong. So I would recommend using that. And if you want to use Argon 2, that's probably okay, but try to, do a little bit of research there. And so you can start with those links that I posted right here. Okay. If you're interested in working with Argon 2 ID, I created an open source project called Hash Tuner, because the thing about Argon 2 ID is you have to tune it properly for like memory and CPU and threads. So this open source project can kind of help you with that. There's a great article about password hashing in the Symfony framework, which is in PHP. There's another one about for doing it in Laravel. There's another great article by Nicholas Grekus that is kind of technology agnostic, really, on hashing in general, and kind of the tensions between having proper password hashing methodologies and not bringing down your server, right? So he'll touch on different resiliency and scalability patterns. So it's definitely a good read. If you operate in on the mean stack, with Mongo and Node.js on the server, I have an article here on doing password hashing on that stack as well. So you should check it out. All right. So now password transport, you should basically, obviously you should use TLS for everything. TLS, it used to be called SSL, but we call it, TLS now for some time. Now you can get TLS certificates for your website for free, right? For some time, you've been able to do that using let'sencrypt.org. The best practice is to use TLS for all of your web application for everything. But if you don't want to use it for everything, definitely use it for login, registration, and password recovery, right? So anytime sensitive data is traveling over the network, make sure that it is over an encrypted transport. And that's what TLS is for. So I'll skip over that. Okay, so another thing to look at is session length and reauthentication. So when a user logs into your application, they are logged in, right? But then ask yourself, how long should they be logged in, right? So for example, if I go to Amazon.com, I'm always logged in, right? They never log me out. However, when I have added things to my shopping cart and I am about to check out, most often Amazon requires me to re-enter my password for safety reasons, right? So these are things worth keeping in mind. You should be able to identify things which are safe to stay logged in forever, right? It's basically browsing content, adding things to a shopping cart that's safe. But if you start entering into transactional use cases, like doing a stock trade or actually purchasing items from the shopping cart, that's when you should consider asking your users to re-authenticate to make sure that they are who they say they are, right? So that's kind of, some of those better practices. All right. Now, what happens when you have a compromised account? So, it's difficult. It's a good idea to have an event log in your system to log all events in your system, preferably to a separate data store that is separate from your main application, so that you don't bog down your main application with all of these activity event logs. And for this event log, you could use an SQL or NoSQL solution. A NoSQL solution may make a lot of sense because you would have like a lot of events. You could accumulate millions of events per day, and so trying to scale that in an RDBMS is going to be a lot more difficult than trying to scale that in a NoSQL solution. So that's one thing you could do. So you could use a separate data store to do this with separate credentials, so you could scale it independently. And here you would try to gather as much forensic evidence as practical as people use your application, such that if an account does get compromised, you can try and track as much activity as possible, starting with the original IP address through which the user originally logged in, right? So user ID, IP address, timestamp, and whatever operation. However, if you do all these things, you should keep in mind this thing called GDPR, right? The Global Data Privacy Regulation. Because to be compliant with this, whenever you log information about users, you need to disclose this information to your users. You need to disclose the fact that you log all this information about them, and you need to obtain their informed consent. Yes, and as Meg just pointed out, CCPA as well, right? So whichever your jurisdiction, there are regulatory considerations to always be mindful of whenever you collect user data, right? And you often have to kind of keep that in mind. All right. Okay, so that was a lot. Here's a picture of my pupper. He's a mini golden doodle. His name is Archer. Okay. Now let's look at OAuth. We're going to dive a little bit into what OAuth is and how it's used, and some better practices. Okay, so there are two things to keep in mind. One is authentication. Authentication means, who am I? I am Chris. Then there's authorization. What am I allowed to do? I am allowed to use this application. I am allowed to add items to a shopping cart, right? These are authorization considerations. So when the OAuth standard first came out, it was called and evolved into Auth 2.0. It really focused on authorization. It really focused on what people were allowed to do. And it did not have any specific provisions as to what to do with authentication. It didn't tell you what to do to specifically identify users. So that's kind of what it lacked, authentication and other specific. So to address this limitation, OpenID Connect came to the scene. It's also known as OIDC. And OIDC is a specialization of OAuth 2.0, right? OIDC fits entirely within the OAuth 2.0 spec, and it adds specifics to the authentication areas of OAuth 2, which OAuth 2 says, you figure it out, right? So OIDC figures out what to do there. So it adds authentication, which makes it possible to say who a user is. So that's used all over the place by social media sites and many web applications. Anytime you have a phone app that needs to authenticate with your account, chances are it will be using OIDC as the most secure way to do things. So anytime you are logging into a phone app, for example, and it says log in with your Twitter account, and so it takes you to Twitter, and then it says Twitter asks you, are you sure you want to allow this application to use all your stuff? And you say yes, okay, and then it redirects you, does some handshaking, a token get exchanged, and now you're able to use the app with your Twitter user. Okay. So OIDC supports 4 grant types. You have auth code. It's used to support implicit, but then that got kind of augmented with what's called auth code plus a PKC workflow. I have a link to it. There's resource owner password. You get client credential. So I'm not going to go into all of these. If you want to learn more about these, I got an article here by Keith Casey that kind of goes into all of these. But we're going to look at one of them, which is the implicit flow. But again, it's no longer implicit. It's basically you're using auth code plus PKCE instead. Functionally, it's very similar, but it's a lot more secure way to do this. So I have a link to it so you can learn more about it. I'm not going to dig deeply into it. But this auth code with PKCE is best fit for most web applications. For example, you have a RESTful API, or you have a GraphQL API that is consumed by a single page application or phone applications. And the point is, you don't want the user login or password to be persisted on this single page application. You don't want it to be persisted on the phone application either. So the way it works at a very high level, you have your user that may open the phone app. And when the app opens up, it redirects the user into a web browser to the OpenID Connect provider, which gives them an HTML page that says, hey, do you want to authorize this application to use all your things? And if you say yes, it's going to send back an ID token using redirecting mechanism back to the application. And then the application will take this ID token and then send it to your API. The API is going to validate your ID token based on a set of shared secrets with your OIDC provider. So in most cases, the areas in pink are your code, right? Your application and your API. Your phone app is your code and your API is your code. And most often, you're using a third-party OIDC provider. Okay, so if you're working with OIDC, there are some kind of high-level better practices. Ensure you're using TLS for all communication channels. If you're working with an OIDC server, make sure you register the proper redirect URLs. I have a link here to ensuring proper token validation. There are JWT tokens, pronounced JOT tokens. There are some better practices there as well. Don't include sensitive information in your JOT token. If you store this JOT token as a cookie, then try to make it only HTTP only and secure, so that it's harder to exfiltrate through JavaScript, so that if you have a cross-site scripting vulnerability, then it's harder for the hacker to exfiltrate your JOT token. Try to use well-tested OIDC client libraries as well, and well-tested OIDC servers. Okay, so there are some open source OIDC servers. In PHP, I actually contributed to a Symfony bundle called Auth 2 bundle. I helped migrate them to Symfony 4.4 and Symfony 5. That was last year. And then on Friends on Symfony, I also contributed 2 pull requests, and those were sitting dormant for a while. And then that got all picked up, and now there is new life in this project as well. So you can check this out, this project as a server as well. There are some open source client middleware libraries. You got Passport.js, you got OIDC client.js, so you should check this out as well. In .NET, there's a great OIDC server called Identity Server 4. Yes, if you search for Identity Server 4 in .NET, that's an open source OIDC server, which is great. So highly recommend it. I had a slide where I plugged them, and then I lost that slide, so I have to put them back. Okay, so lastly, let's look at resource access and multi-tenancy. We're almost done. There is if you look at this article, OWASP broken access controls, I highly recommend it. It's a very simple concept. Let's say your application shows a user's report, right? So at some point, a user has their own reports, and they navigate to their report and they look at their report detail, right? And so they clicked on a link that takes them to their report with ID 4, 8, 15, 16, 23, 42. I don't know if anybody recognizes those numbers. But so what happens? So if I look at this report and I'm logged into my account, there you go, Mark. If I look at my account, I know this is my report. It has this ID, right? But now what happens if I change the numbers, right? If I increment the number by 1 or 10 or whatever, am I going to see somebody else's report, right? And this is where multi-tenancy comes in. Anytime you access a resource by ID, you have to validate that the person accessing this resource by ID is actually entitled to seeing this resource, right? And that's business logic that you have to put into your code. And I can guarantee you, you all have an application right now that is vulnerable to this. Think of anything that you are accessing by ID. What happens if somebody puts another ID in the URL? So some folks have said, well, you know, we could be using UUIDs. Yeah, there you go. Show card equals 34. Absolutely. You could be using UUIDs. Those are non-guessable. Yes, but that's security through obscurity. And also, if UUIDs are in a URL, they're going to show up in the HTTP refer headers as people navigate to other sites from your site and they click on another site from your site, for example, right? There are always ways where identifiers can escape, they can leak out. And so you always have to protect resources. And that's what broken access controls are. And there's really no magic bullet here. This is all business logic that you have to put in your application and you have to check for those things. And these things, and this always scares the daylights out of me because these issues creep up in the life cycle of your application. You build your application at first and you're like, oh, okay, you remember to do it. And then 3 months later, you add another feature where you get a resource by ID and you forget to do it. And then it's super bad. So anyway, and it's bad enough when you have, because SaaS products, software as a service products, support multiple companies with multiple users, right? So it's bad enough to have a user access another user's information, but it's even worse when a user accesses another user's information from another company that's in your system, right? It's a real nightmare. So that kind of keeps me up at night. Anyway, so that was for low-level vulnerabilities. So I'd like to finish with architectural considerations. And I just want to look at securing data stores because you do not, whether it's SQL or not NoSQL, you do not want to expose any data store to the open internet. There should not be a publicly routable IP address to your data store. Those should live on a private network with a web server. Only the web server should be able to connect to your data store, whether it's SQL or NoSQL. You should definitely set passwords and use encryption keys if available. But this is how there are thousands of MongoDB database compromised. It's really not MongoDB's fault here. With MySQL servers, I would never think to put a MySQL server on an open network, but and by and large, people don't do that, but people do that with MongoDBs. For example, for some reason, people like to do that with MongoDB, and it's bad. Again, it's not MongoDB's fault. You should just not. It's just a data store that you should never put on an open network. So also, if you work with any kind of data store, you should use the least privilege principle. If possible, whichever user your web application uses to interact with your data store, that user should have very restricted privileges. You should only allow them to select, insert, and update records. Should you even allow them to delete records? Because do you ever actually delete records, or do you actually do soft deletes? And if you have to delete records, can you just do that as an offline process with kind of dedicated credentials? So that's something to keep in mind, right? Least privilege principle kind of helps mitigate the impact of getting owned. Or views, yes, database views, works as well. So try to create multiple users to mitigate the impact of hacks. You could have a read user that can only do selects. You could have a write user that can only do inserts and updates, for example. And then when you think through network system and design, remember that for each machine that you put on the internet, there is an operating system on top of which you have low-level services called daemons that run on top of it, which could be SSH, Nginx, Mongo, MySQL. These are low-level services on top of which applications run, like Node, Symfony, Rails, Django, on top of which you have framework plugins installed through Composer, Gem, or NPM, on top of which finally your code runs. So anytime you put a machine on an open network, the very first thing that's going to happen is you're going to get an onslaught of brute force credential attempts against any open daemon that is open on any port, as well as low-level hacks like buffer overflow attacks on any of those daemons. And when those are successful, then they can compromise the entire operating system, which then allows them to compromise your entire application stack, including exfiltrating user information from your web application. So that's one angle. Anytime you put a machine on the internet, these things will happen. Now, if you've reasonably secured things, attackers are still going to come at you through those OWASP hacks, right? Everything we looked at this presentation are web application hacks. They're going to try to infiltrate your application through those OWASP hacks, and then they're going to try to compromise everything. So when you think about a network system in design, you want to reduce cross-contamination to isolate each service on its own machine. Whether it's a container, VM, or hardware, you want to have each service on its own machine. Do not run unnecessary services. Try to keep things securely patched. Try to have strict network restrictions on cross-machine notification. And nothing can connect to your data store beside the web server. So just to show you an example of a wildly insecure setup, this is what happens every day today, right? People put a data store on the open internet, like their Mongo database, and then they put web servers in front of them, again, on the open internet. They do that, and then they put a load balancer in front of all of it. And then they do the same thing with another application. Right. So attackers now look at your load balancer and they're like, well, that's a cool load balancer, bro. And they're going to go around it, and they're going to start attacking all your web servers through low-level hacks and high-level hacks, and they're going to start attacking your data stores through all those vectors as well, right? So that's why it's always dangerous to put all those things on open internet networks. And they're going to attack you on a full stack basis with both low-level buffer overflow, low-level credential brute force, as well as the OWASP hacks, right? So you want to try to confine attackers to OWASP hacks. So a more secure way to look at it would be to kind of have a bit of network segmentation, where you have a network for your first application, network for your second application, you get your data store, you get your web servers, and you put a firewall between the two, so only the web server can talk to the data store. And then you have a firewall in front of each network. And then you have your load balancer that can only communicate very specifically through the firewall, through the layers below it. You might have a VPN network for your first application, another VPN for your second application, so your DevOps folks can go in and do their things. So if you do something like this, for example, that's one way to do it. Now you are confining attackers to OWASP-only attack vectors, and that's a much better posture to have. So that's kind of the benefits of all of this. So, all right. Finally, if you're using credentials, never check credentials into Git. In your source control system, you do not want to put any password, any keys, or things like that. That includes, so do not ever check credentials into your Git repo, whether it's data store credential for like MySQL, Mongo, or your Amazon AWS keys, third-party API credentials. You never want to store these things into Git. If you ever do, the only safe thing that you can do, because Git never forgets, is to expire everything immediately and generate new credentials. So to store credentials, you should look at .env files. I have links on how to use those in PHP, Node, Ruby. If you're using Ansible and you want to encrypt credentials, you might consider Ansible Vault. I have a link to that as well. That's a good thing to keep in mind. So, all right, I'm almost at time. Actually, I'm past time. So anyway, InfoSec is a mindset. It is our collective responsibility, from executives, managers, software engineers, DevOps engineers. Try to subscribe to a number of InfoSec mailing lists. I have them here. There are a lot more, but these are some of the few that I subscribe to. And when someone gets owned, do not laugh at them, because it could very well be us. So that's that. And yes, thank you. Here are the slides. Sorry for going over. Thank you, everyone. Really appreciate it. All right. I will be offline. You can find me in the chat thing to ask me questions on the chat. Feel free to, send me messages. I will be sticking around because we're way beyond time. So thank you, everyone.
Great. Thank you so much for the presentation, Chris. You actually have about 4 minutes before your session is up. You can go ahead and take any questions in that time if you'd like to.
Oh, okay, cool. All right. So I am reading the chat right now. Again, feel free to go to this bit.ly URL to download the PDF, which is going to have all those links. It's a PDF with clickable links. So you can get all that. And if you have questions, I am looking at the chat right now. Let me see if the Q&A had the Q&A window had some things. Okay, so Meg had a question about the slides. So yes, we're good there. Yes, Garrett mentioned I've had a ton of false positives evaluating a static code analysis tools, almost to the point of being unusable. My favorite was it complaining every time I had to check the date in business software. How do you decide what threshold should be for proceeding, or are tools better now? Yeah, so I've run into that with SonarQube, and there are thresholds that you can configure in there. So we kind of did that. Most tools are pretty configurable, and you can make exclusions. And then, like, for example, I can put comments in the code because it kept flagging things in my CSS, and I was like, okay, I get it, but no, right? And so you would put like @noSonar in a comment in your code. It's not great because you're kind of littering your code with like noSonar, and it's kind of not great. So, but yeah, Garrett, that's a really good point. Like sometimes static code analysis tools can have some false positives. I would kind of recommend giving this another try though, see what it feels to you, what it feels like to you, you know, because they do evolve pretty well. And is keeping a record of several old passwords for every user not an additional security risk? Yes, really good question. Obviously, so the way I've done it is, remember, you're only ever hashing passwords. So what you do is you don't keep records of the actual passwords in plain text. You remember their old hashes. And so if they enter a new password, you run that new password against the last 5 old hashes. And if there's a match, then you tell them, oh, nope, sorry, you've used the same password, right? That's kind of what you can do there. And it works well. And so it's not really as far as I know, at least, it's not an additional security risk as long as you do never store password in plain text and you're actually using something like bcrypt, right? So, and then the next question by Kwon Chen, having to wipe password before pushing is tedious. Any way to automate that process? So Kwon Chen, I think you're referencing about having passwords in your source code, right? And okay, and looks like we are at time. So anyway, really, you really do not want to have passwords in your source code. So check out .env files, right? I have a link to how to use .env files, and it will make things easy for you to work with. Okay, cool. So it looks like we're at time. I'll be around online, so feel free to send me direct messages in the 6 Connects software. And thank you, everyone.